Morning, everybody. We're starting a few minutes late, but I'd like to introduce our guest speaker, Aarti Alaya. She's a gastroenterologist in Woodbury, Ontario. I'm just going to go over this is the series 18 of the VT Seva, which is an organization volunteering together for Seva, started by His Holiness Chinajira Swamiji. VT Seva essentially comes to the rescue of people who are in disasters like natural calamities. We've been, generating donations from various sources for any kind of calamities like earthquakes or floods anywhere in the world actually. But it started as Vikas Tarangini in India more than 30 years ago. In America and other Western countries, it's known as VT Seva and it's been ongoing for about 18 years now. This particular focus is on wellness and health here and also nutrition. So every week we donate healthy nutrition, which includes fruits and nuts, to people who are underprivileged, particularly people who are homeless and also who have mental illness. So it's a double whammy for them. I don't want to delay anymore, but I'm just going to get started with. So here the focus is health and wellness series. This is series 18, and we've had donations for more than 31 weeks now. How do you get enrolled in this? Is the following slides show you the website how to get involved. You can get involved as a donation. Next one, yeah.
I'm sorry, keep going.
Yeah, keep going.
Okay.
Either three ways of getting is one, you can volunteer your time in person or even remotely. You can help by, obtaining some donations, or you can be a leader. And there are some courses that we groom one in. So the health and wellness series I alluded to is the 18 series, and this is how you can. The website is there. Any amount, even $15, $19 a week is adequate for us. And without any further delay, I will introduce Dr. Aarti. She's actually second generation. Her dad was a physician as well. She went to Jefferson University
For residency and
for
fellowship.
residency and fellowship. She's originally from Tom's River, but now lives in Melton. I'll get it started. Thank you so much.
All right, good morning. So why do we want to talk about gut health? Common symptoms many people complain about include bloating, gas, constipation, acid reflux, fatigue, and brain fog. However, it's more than just that. These are signals from the gut. Really, gut health is important because the intestinal microbiota influence multiple physiological processes throughout our body. They include immune function, metabolism, and neurological signaling, as well as protection against disease. So, what is the gut microbiome? The microbiome is the collective genetic composition of all the bacteria present in a microbial community, while the microbiota are the actual bacteria that are present. The microbiota have are arranged in a broad characterization from very broad to very narrow, follows phylum, class, order, family, genus, and species. In the GI tract, there are predominant bacterial phyla, including Bacteroides, Firmicutes, Actinobacteria, Proteobacteria, and Verrucomyrobia. Now, these all produce their own genetic components, proteins, and each person has a very unique microbiome. So it's not just the specific microorganisms that inhabit their environment, but also their relative abundance and diversity that we care about. Metagenomics is actually the processing of these micro gene sequences, and they help us understand what these microbes are producing. There are 38 trillion bacteria found in each person. That's equivalent to the number of human cells in the body. So healthy versus an unhealthy microbiome. Our intestinal microenvironment not only consists of microorganisms, but our intestinal epithelium. And our immune system is largely located also in our gut. And we've mentioned the richness and the relative abundance and diversity of microbial communities. In community 1, as compared to community 2, those are the same bacteria, but there's a difference in them. We care about having diversity and abundance. So we don't want to predominate with just one type of bacteria. This is also affected by external factors, including use of antibiotics, our birth mode, our diet. And it seems that these are most influential at an early age. By the age of 3 years old, the microbiome, after the age of 3 years old, the microbiome in the colon remains remarkably stable over time. And the metabolites that our microbiome produces can affect either beneficial or harmful effects on us. This is a comparison of what is a Western diet versus a non-Western diet. In this case, we placed Mediterranean diet. Now, as you can see, the Mediterranean diet, or I'll start with the Western diet, as we all know. The Western diet is high in saturated fat, refined sugars, salt, sweeteners, while being low in fiber. And it's characterized by overeating, frequent snacking, prolonged postprandial states. And this dietary pattern negatively affects our gut microbiota. It drives intestinal barrier dysfunction, increases intestinal permeability, and it creates low-grade inflammation. In contrast, the Mediterranean diet, or a non-Western diet, predominantly consists of fruits, vegetables, whole grains, legumes, nuts, seeds, fruits, oil, olive oil as a principal fat source, moderate amounts of fish, dairy and cheese, particularly yogurt and cheese, and low amounts of processed or red meat. As you can see on this side, we have an increase in gut bacteria promoting intestinal health. And in this side, the gut bacteria actually promoted defective intestinal barrier. We'll get into that. Here, you see the gut microbiota with each diet, the Western diet and the non-Western diet. These are different enterotypes. And through metagenomics, we've identified which clusters are apparent in which type of diet. Each has its own specific metabolic features. And the prevalence of this can depend on long and short-term dietary habits. There's a connection, animal with the gut, an animal versus a plant-based. Eating either diet can rapidly alter our microbial gene expression. And the primary metabolic products of our gut microbiota are short-chain fatty acids. And these are the most important ones, particularly acetate, butyrate, propionate. Butyrate is responsible for most of our energy that serves our colonocytes. And these are our better signals to our brain and to the rest of our body. We want our gut to produce these. We want our gut microbiota to produce this. As you can see in the Western diet, it's not well produced. So what do gut bacteria do? They perform major functions, metabolic functions. They can, beyond energy, they can synthesize vitamins like vitamin K, B12, folate. They can facilitate absorption, calcium, iron. They also produce neurotransmitters. They can also regulate host metabolism, including producing gut hormones like GLP-1, PYY that control appetite, insulin sensitivity, and glucose tolerance. So these are fundamental. Our microbiota will protect us. They'll develop antimicrobial substances. They'll assist in competitive exclusion, nutrient competition, and reinforcement of our barrier. This will prevent bacterial translocation into our bloodstream, and which later could lead to tissue injury and infection. So we often think of our gut as our second brain. What does your gut tell you? Our gut communicates with our brain, it truly does. It influences our mood, our immunity, our hormones. A balanced diversity of bacteria in our gut is associated with gut-brain axis and incense between our central nervous system and our enteric nervous system. When we have a leaky gut, leads to numerous diseases. So here our gut-brain axis involves complex crosstalk between the endocrine, which is the hypothalamic pituitary adrenal axis, and our immune system through cytokines and chemokines, and as well as our autonomic nervous system. And you can see that many things can affect our gut-brain axis. Our stress, our mood, anxiety levels, these all can come from our gut. Our brain also has input into our gut. It can affect motility, secretion, hormonal balances. While most microbiome research centers on our colon, it is important to briefly discuss other areas where our gut microbiota can affect our oral cavity as well as our small intestine. Now, these areas have substantially decreased amounts of abundance by magnitudes compared to our colon. But the oral microbiome has been implicated in both local disease states such as dental caries, periodontitis, oral cancer, as well as distant diseases including inflammatory bowel disease, pancreatic cancer, obesity. Now, the environment in the small intestine is very different than the large intestine in terms of surface area, motility, oxygen saturation, proximity to getting nutrients, bile acids, and our pancreas enzymes. Therefore, it supports a very different microbiome. In the small intestine, our microbiome is constantly very dynamic, and there's a very significant temporal variance within a matter of hours after our dietary behavior. This is in contrast to the colon. So dysbiosis can occur. We want to avoid dysbiosis. It's the harmful imbalance or alteration of our gut microorganisms. And several GI states can be affected by dysbiosis. Most notably is Clostridium difficile infection, a deadly bacteria that can cause significant mortality and morbidity. Less definitive problems can include inflammatory bowel disease as well as irritable bowel syndrome. Not only a decrease in bacterial richness and diversity can cause this, but a disruption also can be caused by an excess of bacteria in the small intestine called SIBO, which can also affect a lot of signals that our gut receives. We want to favor that our gut can respond to these insults and develop a better homeostatic mechanism to bring us back to our baseline. That's the goal. Some of the things in our armamentarium include probiotics, prebiotics, symbiotics, fecal microbiota transplant, live biotherapeutic products. Prebiotics are non-viable food ingredients, and theoretically they increase the health-promoting bacteria. For example, fermentation of prebiotics to short-chain fatty acids can result in anti-inflammatory properties. Probiotics, when administered in adequate amounts, they can confer health benefit on our host. They exert their beneficial effects through competing and inhibiting pathogens from adhering to our gut epithelia and improving our gut barrier anti-inflammatory effects and support our immunity. Symbiotics are just a combination of both of these and are believed to have a synergistic effect on our microorganisms. So our intestinal barrier is very important. It's a semi-permeable cell layer, and it's united by tight junctions, these areas between our cells. Super important because they prevent this environment from connecting to this environment. This is our intraluminal area. It's got pathogens, it's got food particles, it's got antigens. And this is our bloodstream. Our tight junctions are extremely complex structures and have numerous redundancies and backup systems to make sure they work properly. It serves to regulate nutrient and water entry and prevent the undesired compounds from entering our portal circulation. Now, zonulin is a protein within the tight junction, and it's the modulator. It is the modulator of intercellular tight junctions. So we want our gut bacteria to not affect our zonulin. We want it to affect it in a positive way. When we eat gluten, which can be inflammatory, when we have an altered microbiome, we're eating ultra-processed foods, we have inflammation going on in our body, we're ingesting toxins or exposed to toxins, we have increased stress, physical or psychological, we compromise the gut barrier. The zonulin protein is not being well made, and openings are occurring in our tight junction, and we're getting paracellular as well as transcellular transfer into our bloodstream. We're seeing things that shouldn't be there, and they're causing a low level of inflammation and causing a low level of abnormal immune reaction. This bacteria in here, the gut bacteria, all have endotoxins in them. We do not want them to enter and cause systemic inflammation. We want to live in an environment that looks like this. We do not want to get into an environment that looks like this. This is largely a function of our lipopolysaccharide region. It's not a layer of the gut itself, but it's actually a structural component made of bacteria. And a normal gut microbiota will create a nice thick mucus layer in our gut. This is the lipopolysaccharide. It's a large glycolipid, and it constitutes the outer membrane of gram-negative bacteria. It's essential for bacterial surface integrity. It acts as a potent trigger of the host immune system when it enters systemic circulation. Under normal conditions, it doesn't enter systemic circulation. But in dysbiosis, we start to see mild inflammation entering our bloodstream and sending pro-inflammatory cytokines. With a leaky gut, now, we don't have much lipopolysaccharide at all. All the gut bacteria and their endotoxins are finding their way through our gut intestinal barrier into our bloodstream and causing an inflammatory response. And depending on our genetics, where that inflammatory response ends up leads to disease. It promotes insulin resistance, contributes to obesity. It's implicated in type 2 diabetes, non-alcoholic fatty liver disease, cardiovascular disease, found in atherosclerotic plaques. It promotes plaque instability. It activates platelets. It triggers our thrombotic cascades. In heart failure patients, endotoxins are elevated in decompensated heart failure, and they contribute to cardiac and vascular dysfunction. In neurodegenerative conditions and autoimmune conditions, this state is increased. The systemic inflammatory state is driven by the LPS layer. So what shapes our microbiome? There's more than this, but major influences are diet, environment, sleep, stress, and our genetics. Clearly, diet is a very large factor, but we're constantly in this environment exposed to stress. Some of us are exposed to bad habits. We're getting older. We have genetic predispositions. We want to thrive. We want our healthy bacteria to protect us from this chronic inflammation, because we don't know where chronic inflammation is going to cause within our genetics. It could do something to, depending on epigenetics, it could do anything. So healthy bacteria thrive on plant diversity and fiber. Again, we want short chain fatty acids, but they're produced in the distal colon. That means everything we eat needs to reach our distal colon. It has to get through our oral cavity. It has to get through our small intestine and enter our distal colon. What can do that? Usually, they're called macrobiotic associated carbohydrates. That's fiber. They're resistant starches, pectins, inulin. These enter our lumen and they can reach our colon. The gut microbiota that lives on our colon lining in the lipopolysaccharide region produce short-chain fatty acids from fermentation of these indigestible carbohydrates. These acids nourish the GI tract and they're indispensable for the health of our cells and beyond, to our brain, to our liver, to our immune system. So I mentioned short-chain fatty acids are the products of the gut microbiota, and they reach the brain through circulation. The most important ones, acetate, butyrate, propionate. Sodium butyrate has a neuroprotective effect. It promotes cell proliferation and differentiation in our dentate gyrus of our brain. It increases our brain-derived neurotropic factor. We like this one. We want high levels of this. And glia-derived neurotropic factor. Butyrate has anti-inflammatory actions in the gut and brain, preventing the induction of TNF-alpha by the LPS layer via suppression of nuclear factor beta. Butyrate stabilizes hypoxia-inducible factors, critical in maintaining gut barrier integrity against the influx of toxins. When reduced, dysbiosis occurs. The Western diet reduces populations of bacteroides and increases Firmicutes and proteobacteria. These shifts are associated with cognitive impairment. Anti-inflammatory lactobacilli are reduced by Western diets. This can affect our memory. Bacterial species Akkermansia muciniphila is reduced by Western diets. Akkermansia species is negatively associated with inflammation and obesity. As you can see, we want to improve our gut bacteria. We want to increase its diversity and its richness. And a decrease in this causes dysbiosis and results in inflammation in many organ systems. A non-Western diet includes colorful fruits, vegetables, inclusive of polyphenols, antioxidants, flavonoids. Everything here has a good component: polyunsaturated fats, monounsaturated fats, short-chain fatty acids are produced. Studies have shown that the Mediterranean diet is associated with beneficial bacterial composition and improved gut microbiota. Mediterranean diet is based on locally grown, minimally processed, infrequent red meat. We discussed that. There was a study in New England Journal of Medicine 2013 that showed the Mediterranean diet with olive oil or nuts reduced incidence of major cardiovascular events. So our microbiome has a huge role in how our cellular aging. When we eat ultra-processed foods, we cause cellular aging. We cause oxidative damage, telomere shortening, advanced glycation products, damage to our DNA. We cause immunosenescence changes in our adaptive immunity, reduced production of antibodies, poor vaccine tolerance or response, inflammation, altered innate immunity, and reduced activity of our killer cells and chronic systemic inflammation with elevated levels of inflammatory markers, IL-6, TNF-alpha, and CRP. When we avoid healthy diet, changes in body composition, including reductions in our muscle mass, increased adiposity. Through poor diet, changes in your gut physiology, the quality of the intestinal mucin is affected. Our gut permeability starts to increase. We develop reduced transit times. There's increased risk for Helicobacter and SIBO. And what we do not want is neurodegenerative changes, which could be dementia. Polyphenols, they're compounds that are derived from plants, such as fruits, vegetables, herbs, spices, dark tea, dark chocolate, wine. They can act as antioxidants, meaning they can neutralize harmful free radicals that would otherwise damage our cells and increase our risk of conditions like cancer, diabetes, and heart disease. They're thought to reduce inflammation, thought to be the root cause of many chronic illnesses. By ingestion of polyphenols, we may lower our blood sugar levels, contributing to lower risk of type 2 diabetes. They may prevent the breakdown of starch into simple sugars, lower the likelihood of blood sugar spikes after meals. They help stimulate the secretion of insulin. Adding polyphenols to our diet may improve our heart health, largely due to the antioxidant property, which reduces chronic inflammation. Just a simple risk factor that affects heart disease. Polyphenols benefit digestion. They promote the growth of beneficial gut bacteria while fending off harmful ones. Evidence suggests that polyphenol-rich tea extracts can promote the growth of beneficial bifidobacteria. Green tea polyphenols may help fight harmful bacteria, including C. diff, E. coli, salmonella, improve symptoms of peptic ulcer disease, inflammatory bowel disease. And there's emerging evidence that indicates that polyphenols may help probiotics thrive and survive. So fiber, food for your gut bacteria. These are sources that we're all familiar with. Lentils, chickpeas, beans. Prebiotics are basically resistant starches, inulin, pectin. They function as a food source for your gut's microorganisms. And again, they have to reach the colon. They need to bypass digestion and make it all the way down there. Like fiber, resistant starches end up as the main food source for your colon bacteria. They produce butyrate, which helps with water and electrolyte absorption, immune system, and anti-inflammation. Inulin is a prebiotic fiber in many plants. It can help you feel full for longer periods, assisting with overeating, helping with bowel movements. It can help lower your LDL, stabilize your blood sugar, increase and maintain the good bacteria in your gut. It may also help reduce your risk of colon cancer. Pectin is a type of gel-like starch, often used to create jams and jelly. The starch has antioxidant, anti-tumor properties. It may enhance the skin cells of your intestinal lining, decrease the ability for bacteria to take root. When prebiotics are broken down by microorganisms in your gut, short-chain fatty acids are created. As a result, they do a number of things, like provide energy to your colon cells, to help with mucus production and aid in anti-inflammation and immunity. They help bowel movements. They produce neurotransmitters that go back and forth between your gut and your brain to trigger mood changes and other processes. They stimulate your body to make hormones that aid in digestion, appetite suppression, help your bones mineralize and absorb calcium and phosphorus. And they enhance your body's anti-inflammatory response. Probiotics examples are like yogurt, ghee, kefir, fermented foods, idli, dosa batter. They're live microorganisms that have been isolated from human intestines and are shown to have beneficial effects when they're consumed in adequate amounts. They can also be found in kombucha, tempeh, miso, sauerkraut. In order to be considered a probiotic, after ingestion, the microorganisms need to survive the stomach acid and bile so they can make it all the way to your colon to meet up where the other live microorganisms are. They need to be able to survive in that environment. And the more variety of these healthy microorganisms you have, the more they can do for you. Our environment, antibiotics, they play a role in this. They can affect our microbiome. Traditional lifestyles often supported healthier microbiomes, but earlier epidemiological evidence revealed a 4-fold increase in obesity risk within 15 years of emigrating to the US compared to populations remaining in their birth country. Movement improves gut health. Walking, high-intensity interval training. Benefits are many. They improve our gut microbiome composition and diversity. Regular physical activity enhances microbial richness. It increases and promotes the production of health-promoting metabolites. Short-chain fatty acids. It decreases the ratio formicades to bacteroides ratio, a marker often elevated in obesity. In 2025, a pooled analysis randomized controlled trial found that high-intensity interval training also increased total short-chain fatty acids by 30%, including acetate by 27%, propionate by 28%, and butyrate by 43%. While moderate exercise intensity did not significantly change things. This could be a key determinant in metabolic benefits. The effects appear to be independent of diet and are contingent on sustained exercise. Sleep and the gut. Poor sleep can affect our gut. It significantly affects the microbiome. Sleep deprivation, circadian rhythm disruption are associated with reduced microbial diversity, altered bacterial composition, and dysbiosis. The relationship is bidirectional. Gut microbiota influence sleep through metabolic and neuroendocrine pathways. Poor sleep is associated with lower richness. Altered pathways include amino acids production, vitamin synthesis, neurotransmitter production. In older adults, shorter sleep duration is associated with an increase in pro-inflammatory bacteria, whereas increasing sleep quality is positively associated with beneficial bacteria. The gut-brain axis. So 90% of serotonin is produced in the gut. It may affect our mood, our cognition, our anxiety. Stress may cause symptoms. Lifestyle practices that help include yoga, meditation, walking. Meditation also affects gut health through bidirectional communication. Psychological stress activates the hypothalamic pituitary adrenal axis, releasing corticotropin releasing factor. Meditation counteracts these stress-induced changes. It reduces sympathetic nervous system, decreases pro-inflammatory cytokines, promotes beneficial microbial metabolites. It may improve tryptophan metabolism pathways, influencing mood, anxiety through the gut-brain axis. Long-term meditation practitioners show enrichment of beneficial bacteria, including Faecalibacterium, Rosburgia, and Leptospira. Genera associated with short-chain fatty acid production, improved GI function, immune modulation, and gut-brain signaling. Changes can persist for at least 3 months after meditation programs conclude. Research suggests that meditation depth correlates with distinct microbiota patterns, with deeper meditation associated with compositional differences in gut microbiota. Gut health in the whole body. I think it's evident that our gut and immunity are fairly one. 70% of immune cells are in the gut. Gut bacteria influence hormone metabolism. They influence sex hormones, thyroid hormones, stress hormones, metabolic hormones through direct metabolism, immune modulation, and regulation of bioavailability. Regulates estrogen through the estrobolome, the collection of bacterial genes encoding and sulfating and deconjugating and reactive estrogen, influence circulating levels and bioavailability. These alterations in the estrobolome function due to dysbiosis have been associated with estrogen-related diseases, including breast cancer, endometrial cancer, polycystic ovarian syndrome, endometriosis, perimenopause, and depression. As we know, gut imbalance is linked to many inflammatory diseases, obesity, metabolic syndrome, inflammation. We want to improve our gut health. We want to eat more fiber, increase our plant diversity, eat more fermented foods, sleep well, manage stress, stay active, and reduce our processed foods. We want to aim for about 20 to 30 different plant foods per week. It's very possible because it includes spices. It includes nuts, it includes seeds, it includes legumes, vegetables. So you might think that's hard, but if you're adding turmeric, black pepper, red seed, you're using some vegetables in a scramble, you're You could get up to 15 in just one meal. So it's very possible. I know it sounds like you have to eat 20 to 30 vegetables, but that's not the case. It's not just vegetables. It's anything that's plant-based. Hydration and digestion. Water helps. Our gut changes with age. Aging may cause reduced microbial diversity. It's slower digestion, increased medication use. We have to focus on fiber, hydration, fermented foods, and activity. Practical daily habits. We eat a fiber-rich breakfast. Lunch and dinner, vegetables and legumes. And daily, include yogurt, fermented foods, walking, adequate sleep. Diet and lifestyle shape our gut bacteria daily. Improving gut health supports our immunity, our brain health, and our metabolic health. The gut microbiome is the foundation of health. Take care of your gut, and it will take care of the rest of your body. And that's it.
Thank you.
So basically, that is the start of the health. You know, everything links to the gut.
It does.
So as you mentioned, as you age, it might decrease. How do we improve? Like, for example, for vegetarians, B12 is the deficiency is one. How the gut, I think,
Right.
has to release that. How do we
Right.
cope up with that
So
deficiency?
it's okay to take supplements. That's not wrong. Obviously, we want to do as much as we can through diet, but if your diet excludes certain types of foods, then you need to supplement. As long as you're doing other things, we're really trying to achieve homeostasis. So as much as richness and diversity that you can get, you're doing still other things that are compensative. So if you take a supplement, it's okay. Never need to overdo it.
Okay.
So, what is the role of intermittent fasting on gut health?
So there are different types of fasting. Some people can fast 8 hours, 10 hours, 12 hours, 16 hours, 2 days, 3 days. And each can have a different effect for what your goal is. I think for the everyday purposes, we often say finish dinner early.
Okay.
And go to bed, right? Or don't eat after a certain time. Finish around 5 or 6 p.m., right? By 6 a.m. the next morning, that's a 12-hour fast. It's already a 12-hour fast. So you're not going to necessarily eat at 6 a.m. You might eat at 8, 8:30, 9. So that's already 15. So, you've fasted. What is that doing? It promotes what's called autophagy. Autophagy is a type of stress. It's a good stress. It creates the destruction of bad things. Throws old things in the trash can. Prevents senescence. It helps us develop new cells. That's important, I think. It also sends signals. When you are fasting, your brain is getting a signal to send large, complex motility waves to our gut. These are big waves. And then it can happen with prolonged fasting too. So you can get a gut reset. You can get better digestion. You're getting a clean out. You're getting bile acids that are flowing to cause evacuation. This is important. So fasting can help in that sense and improve our gut bacteria in that sense. Now, prolonged fasting, let's say you're going on a 3-day fast of water or whatever. There is some clarity that can occur with that. Your body is under a stress. I wouldn't do it regularly. But as long as you're supporting your body, hydrating it with water, you're not running a mile when you're fasting, you are promoting autophagy, you are promoting gut clearance, you are promoting neurotransmitter production. Breaking your fast is important. I wouldn't go eat out, take out food when you break your fast. You're supposed to eat something healthy and small and to redevelop that. So there are lots of health benefits, mental clarity, improved immune system, signs of decreased aging that can occur with fasting.
There are a lot of fads nowadays about detoxing and emptying your gut. So people go about and say, hey, your gut's never clean, you want to clean it. Like how you prep for a colonoscopy or something like that. What do you have?
It really
What is
has-
your take on that?
Yeah, so when people come to us and say, I'm gonna do a detox, I wanna take a colonic or a laxative, this isn't cleansing. You're basically just, just letting your stool flow through. It's not changed anything necessarily. It hasn't changed anything. More of a gut detox would be walking in nature, exercising, eating a high fiber rich diet, drinking more fluids. That's a better detox. You're effectively moving good bacteria down to your colon. You're creating short chain fatty acids, and those are the key metabolites that you want created. Now, suppose you're a young person, you went out in college, you're drinking, you're alcohol, you're eating out pizzas, fried chicken, etc. Bad stuff. These young people sometimes want to do that, and I don't know that it makes a difference, but I'm sure it makes them feel better. They felt like everything got shoved out. That's not necessarily health benefit.
So I have seen 3-year-old or 4-year-old having constipation. Why is that?
So our gut microbiome begins the day we're born, even probably in our womb to some extent. It's what your stress level as a mother, your stress levels, your diet, its mode of delivery, vaginal versus C-section. It's breastfed versus not. It's whether you were a preemie and you received antibiotics when you were born versus not, or things like that. So certainly there's lots of problems that can occur, and genetic components, epigenetics, play a role. But if you're young and you have constipation, focus on removing those inflammatory foods and healthier foods in our diet, because we know that health promotes motility, healthy gut, fiber, prebiotics, probiotics. Kids can eat. When patients come to see me and ask, should I take a probiotic? I often ask, can you eat your probiotics? Can you eat them? Can you exercise? These are so valuable that if you just depend on supplements and pills, it's not going to work.
And I think it's a long time I read in a research saying about gut health. The time of the mom, what she ate during the delivery is what the kid gut health, it depends. Is that true? If you eat that kind of food, the kid stays healthy. If you change the diet, it may not.
I do. So, I can't answer that so perfectly, but I think we do know that what the mother is eating does affect the production of the child, right? Our bloodstreams are mixed. There is a mixture, and that affects what develops in our gut. But essentially, our gut and our brain were connected when we were a cell. It came out. And so we know that there are connections there. And our mother's diet does, even your anxiety levels, pregnancy, that matters. That plays a role in that. It doesn't have to, but it can. It doesn't have to. So nothing we're born with has to be the case. We can affect it.
Can change it.
Yeah.
So between, if you look at the Western or allopathic recommendation, eat every 4 hours, snack in between so that your blood sugars are not up and down, versus what comes from yoga, 2 meals a day, and of course some intermittent fasting. Any thoughts about either?
Yeah, I mean, it certainly seems like we had the right idea in non-Western.
Okay.
I think so. But I think we had the right idea because it does help our gut bacteria. We are eating that non-inflammatory diet. We are providing gut rest. We are calm. We're not inflamed by our diet, right? We're our circadian rhythms feel better, we're getting proper sleep, we're not overloading our gut and feeling anxious and bloated and indigestion and constipation. Many reasons people come to see us, and many reasons they want a quick fix.
Mhm.
Quick fixes don't figure
Yeah.
the root cause, they're just treating the symptom. It takes a lot more effort. Lifestyle changes.
One question. As you get older, do you benefit by taking probiotics, prebiotics on a maybe daily or weekly basis
I think you
as
have,
a supplementation?
if you cannot eat it. If you
No
cannot
harm.
eat it, yeah. I think if
There are
you,
so many new drinks that are in Walmart and ShopRite.
I don't think there's anything wrong with that. You have to see how it's sourced,
There
how
are.
it's processed.
There's one there's one karma, there is one drink that comes karma. It has I don't know, so many billions of spores in it.
Yeah.
We tried the karma in order to get better with the stomach condition. It looked like it worked,
Okay.
but after a while it didn't work.
Yes.
Then we tried, this person is what you call diabetic and chronic diabetic. So not constant, I would say periodic, weekly basis, bloating,
Yeah.
going to the bathroom.
Yeah.
So then we tried lactate tablets, assuming that this is a lactose intolerance. It didn't quite work. One tablet didn't really work. So we got fed up with that. And then after that, we got an idea, why not we use lactate milk? There are lactate milks coming in the, now you have milks like so many types, almond milk, silk milk, and which are non-milks, and also lactose milk, which they somehow separate the lactase enzyme and reconstitute the milk. That helped quite a bit.
Okay.
So I was thinking that maybe it is a good idea to take some probiotic. Do you have any recommendation which brand is good?
No, I don't really. Most brands are, I would always look at them, I don't recommend anything particular. But you just see to make sure they're sourced properly, not chemicals, most of these they're doing fine. So there's nothing one that's greater, and it
Some
truly
of them
depends
are
on.
very less expensive,
Yeah,
some of them are highly expensive.
yeah, right.
They're so highly expensive. So I don't know the actual benefit of either using one of these.
I do often think, you're affecting your gut bacteria in a temporal way. This is a very temporary way. These are drinks that you're drinking with bacteria that you're trying to affect the microenvironment, right? But what environment are you affecting? Are you affecting a leaky gut? Are you affecting a low liposaccharide layer gut? I don't know. What I do know is that you have to build a good gut barrier first. Add in probiotics, then they will thrive. They will work together synergistically and promote health and good benefits. How that feels in your particular situation with your particular medical disease is always different, right? And how long you've had that medical disease and consistent, so the day-to-day is never a judgment. It's a longer consistent.
Yeah, I agree. Day-to-day is not a judgment,
Yeah.
and also one person
Yeah.
is not a sample.
It's
You
not,
really
but
need a
at
lot.
the end of one does make a difference. We're all different. My microbiome is very different than your microbiome. So, you know, what you do might work really well for you.
Yeah.
And so, when it comes to health, that N of one is probably, it's not, you can't write it off. You can't write it off.
Thank you.
So I know that it's time, right? Like,
Yeah.
Okay.
It's 11:06. Yeah. Thank you so much, Harpreet. And I would like to welcome our president to just give a small token of appreciation to
Please go
Harpreet
ahead.
for so much time and
Thank you.
Thank you, appreciate it, it was a pleasure.
Thank you so much.
Thank you.
we had a lot of hiccups in the
Yeah, no
beginning
problem.
with the-
Sorry about the delay.
Listen,